go. Welcome. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on to section 5.5. First, I have a couple of questions on WebAssign, which is why I have it up over here, that we're going to look at from yesterday. And then I have another message I want to give all of you. So Cengage is the company that provides us with the textbooks and WebAssign. And as some of you are aware, that got the loose leaf copies from the bookstore, there were a couple of chapters missing. Chapter 14 was missing, which I emailed out to everybody. And most of you don't even know it yet, but chapter 8 is missing, and I plan on emailing that out to you before we get there. However, the company has decided that they made a mistake, or for whatever reason they want to correct things. So I was asked to email my students, and I will be sending out an email, but I just wanted to put this on there. So two different ways to maybe catch people. As you can see what it says here, if you bought the bundle, you want to swap it out for the correct one, you can do that by making an appointment with the bookstore, and I guess you would call them, or next week apparently they can go in and swap it out. Anyway, so that message is there, and if you forget it, you can always go back and look at the video. I will be sending out emails later today, but just to let you know. And again, if you don't want to bother with it, that's fine. I've already sent out chapter 14, and I will be sending out chapter 8 right before we start doing chapter 8. Anyway, okay, so enough of that. Now we're going to, let's see here. We're going to take a look at some problems. This is from section 5.4, and this is number 19, which you can see over on the left side of the screen there. It says evaluate the expression x cubed minus 5x squared minus x plus 25. And we're going to look at part A, even though they got it correct, we'll do that. So part A, x is equal to 5. So we get 5 cubed minus 5 times 5 squared minus 5 plus 25. 5 cubed, 5 times 5 is 25, times 5 is 125, minus 5 times, again, you do the exponents first, 5 squared is 25, minus 5 plus 25. 125 minus 5 times 25, minus 5 plus 25. 125 minus 125 is 0. Negative 5 plus 25 is 20. So our answer for part A is 20. Now let's go back and take a look at part B. Part B, x is negative 5. We have to be careful. The entire quantity, negative 5, goes in place of x. So we get negative 5, the quantity cubed, minus 5 times negative 5, the quantity squared, minus negative 5 plus 25. It's always a good idea to put parentheses around the number you're substituting for the variable. So now negative 5 cubed, that is negative 5 times negative 5 times negative 5 would be negative 125. Then minus 5 times negative 5 times negative 5 would be positive 25. Subtracting a negative is like adding a positive. So we get that. But then negative 5 times 25 is negative 125. So we've got what? Negative 250 plus 30, which would be negative 220 as our final answer. Any questions about how I did that one? Ready? Let's take a look now at problem 23. And this is the reason that I have us looking at the WebAssign screen because of the graphs that they have there. So number 23 says construct a table of solutions and then graph the equation. All right, so we've got y equals negative 3x squared plus 3. And we've got negative 2, negative 1, 0, 1, and 2 as our x values. So if x is negative 2, y equals negative 3 times the quantity negative 2 squared plus 3, which is negative 3 times 4 plus 3, which is negative 12 plus 3, or negative 9. Okay. If x is negative 1, y equals negative 3 times negative 1, the quantity squared, plus 3, which is negative 3 times, well, negative 1 times negative 1 is positive 1. So we get negative 3 plus 3, which is 0. If x is 0, y equals negative 3 times 0 squared plus 3, which is negative 3 times, well, 0 squared is 0 plus 3. Negative 3 times 0 is 0. 0 plus 3 is 3. If x is 1, y equals negative 3 times 1 squared plus 3, which is negative 3 times 1 squared is 1 plus 3, which is negative 3 plus 3, which is 0. And finally, if x is 2, y equals negative 3 times 2 squared plus 3, which is negative 3 times 4 plus 3, which is negative 12 plus 3, which is negative 9. All right, so now we've got our points. So let's take a look over here at our graphs and see which of these graphs it is. When x is negative 2, y is negative 9. Well, if we look here, when x is negative 2, y is greater than negative 9, way greater. So it can't be this one. Let's see, oops. Over here, when x is negative 2, y is negative 9. So it could be that one. When x is negative 2, y is negative about 15. Couldn't be that one. So really just, and then finally here, negative 2, negative 9 is down here. So just taking that very first point, we can see that it has to be, this one. And if for some reason we couldn't determine it from just that, we could put in additional points to conclude that it was this particular graph. Okay, any questions about that? All right, so now I am going to switch back to our regular screen. And let's see here. So we should be back to where you can see the whiteboard screen. Am I correct? Is that what you can see? Somebody just verify it?
Yep.
Thank you. Okay. So now we're going to take a look at section 5.5, which is adding and subtracting polynomials. First, we're going to take a journey back to chapter 2, where we would have talked about like terms. Okay, so let's sort of reacquaint ourselves with what like terms are. Okay, so let's say I've got 2x plus 3y. Those are not like terms. There's nothing we can do. But if I've got 2x plus 3x, I can add their coefficients and get 5x. If I've got 7y minus 2y, 7y minus 2y, 7 minus 2 is 5, so 5y. Okay. Now, what if I've got 3x squared plus 4x? Are those like terms? They have the same variable. Yes, but they have different powers of the same variable. So those are not like terms. So we can't combine them. All right. Any questions about that before we go forward? All right, so let's go on forward here and let's take a look at some problems. Okay. This says 15x squared plus 10x squared. It says simplify each polynomial and write it in descending powers of one variable. So this is a binomial, but the two terms are like terms, so we get 25x squared. As far as writing it in descending powers, since there's only one term, we can just continue on with that. Crystal, can you block your vision so that we're not all seeing you talk on the phone? It's kind of distracting, but apparently you can't hear me anyway, so whatever. All right. Here we've got 17y squared minus 22y minus y squared. All right. These two are like terms, but this one here is not. So 17y squared minus y squared is 16y squared, and then minus 22y. However, these are not like terms, so I can't combine them any further. They are in descending order. So there's our final answer. All right. How about this one? Negative 3y squared minus y minus 6y squared plus 7y. These are like terms, and those are like terms. Negative 3y squared minus 6 more y squared would be negative 9y squared. And then minus 1y plus 7y would be plus 6y. So here is our polynomial in descending powers or standard form. All right. Any questions there? Okay. Let's take a look at this next problem. 6/7 y squared plus 1/2 y minus 2/3 y squared plus 1/5 y. Let's see here. That. There we go. Okay. So we're going to combine like terms here. And we've got those two are like terms and those two are like terms. All right. Now, 6/7 y squared minus 2/3 y squared, those are like terms, but to add or subtract their coefficients, we need a common denominator. So let's take those two terms and just put them side by side here. Okay. The common denominator of 7 and 3 would be 21. So I need to take 6/7 and multiply it by 3/3 to get 18 over 21 y squared. And then I need to take 2/3 and multiply it by 7/7 to get minus 14 over 21 y squared. Now, 18 over 21 minus 14 over 21 is 4 over 21, and that's y squared. All right. Any questions about that part? Okay, let's take a look at the other like terms. So we've got plus 1/2 y, y, plus 1/5 y. Common denominator there is 10. So this is plus so many tenths y plus so many tenths y. Okay. I'm going to take 1/2 and multiply it by 5/5 to get 5/10 y. 1/5 and multiply it by 2 over 2 to get 2/10 y. 5/10 plus 2/10 is 7/10 y. So not only were we combining like terms there, but kind of a little review of what you have to do to add or subtract fractions. You need a common denominator. Any questions about this particular problem? All right, going on, let's take a look at, let's see, this one. 1.9 m to the 4th power minus 2.4 m to the 6th power minus 3.7 m to the 4th power plus 2.8 m to the 6th power. So first of all, we'll identify the like terms. Those are like terms, and those are like terms. Because we want our answer in descending powers of the variable, I'm going to start out with the largest power, which is m to the 6th power. So let's see, if I've got negative 2.4 m to the 6th plus 2.8 m to the 6th. So basically, what is negative 2.4 plus 2.8? And that would be a positive 0.4. So we get 0.4 m to the 6th. Again, any questions there? All right. And then 1.9 minus 3.7. Let's see. 1.9 minus 3.7, and this is what? M to the 4th. What do you do when you're subtracting a larger number from a smaller number like this? Okay. Basically, you do what? 3.7 minus 1.9, which is going to be, let's see here. It's going to be 1.8, but it's going to be negative. So this is minus 1.8 m to the 4th power. Okay. Any questions about that example? All righty. Let's take a look at this situation. We have 3q squared minus 5q plus 7, that's in parentheses, plus, also in parentheses, 2q squared plus q minus 12. So basically, we're adding two trinomials. Before we combine like terms from the different sets of parentheses, we need to get rid of the sets of parentheses, get rid of the grouping symbols. If there's nothing in front of a grouping symbol, there's basically 1 times the grouping symbol. So we could just go ahead and rewrite the inside contents on the outside. If there's a plus sign in front of the parentheses, it's like a +1 times everything, and distributing that, we still get plus and then what's inside. So now I've gotten rid of the grouping symbols. Let's combine like terms. Those are like terms, those are like terms, and those are like terms. 3q squared plus 2q squared is 5q squared. Minus 5q plus q would be minus 4q, and plus 7 minus 12 would be minus 5. So there's our final answer in descending powers of q. Any questions about that example? Okay, let's take a look at this one. 1/16 r to the 6th plus 1/2 r to the 3rd minus 11/12 plus the quantity 9/16 r to the 6th plus 9/4 r cubed plus 1/12. Again, if we have nothing in front of a set of parentheses, we can just get rid of the parentheses grouping symbol. If we have a plus sign in front, we can just, again, rewrite the polynomial that's inside, but writing it without the grouping symbol because it doesn't change the sign of anything inside. Now, combining like terms, let's see, those are like terms. 1/16 r to the 6th plus 9/16 r to the 6th would be 10/16 r to the 6th, which could be reduced down to 5/8 r to the 6th power. Okay. 1/2 r cubed plus 9/4 r cubed. 1/2 r cubed plus 9/4 r cubed. Common denominator there would be a 4. Okay, so 1/2, I need to multiply it by 2/2 to get 2/4 r cubed. 9/4 is already 9/4. 2/4 plus 9/4 is 11/4. So now I've got 5/8 r to the 6th plus 11/4 r cubed. And then, let's see, what have we got here? We've got minus 11/12 plus 1/12, which would be minus 10/12 or minus 5/6. So there's our final answer there. Any questions about that problem? Okay, how about this one? It says use vertical form to add the polynomials. 3x squared plus 4x plus 5, 2x squared minus 3x plus 6. And it says that we are going to add these polynomials. Well, let's see here. 3x squared plus 2x squared is 5x squared. Plus 4x minus 3x would be plus 1x. Plus 5 plus 6 would be plus 11. Now, I mentioned this before. I still saw some people doing it, so I'm going to mention it again. Even though technically there is an implied 1 there, WebAssign doesn't tend to recognize it and tends to mark it wrong. So you don't need, in fact, don't put the implied 1 coefficient in front of the x. I'm not saying x equals 1. I'm saying that x equals 1 times x. Okay. All right. Now, here's where things get a little bit trickier. Let's say we've got 3a squared minus 2a plus 4 minus the quantity a squared minus 3a plus 7. Again, nothing in front of the first set of parentheses, so we can just drop the parentheses. But now, with a subtraction sign in front, it's like we're distributing a -1 to each term inside the parentheses. Something times -1 is going to change the sign. So this is going to be minus a squared, minus times minus plus 3a, minus times plus minus 7. So when we bring that trinomial outside, all the signs of each term have changed. Any questions there? All right, combining like terms, that goes together, that goes together, and that goes together. 3a squared minus a squared is 2a squared. Minus 2a plus 3a is plus 1a. And plus 4 minus 7 is minus 3. So there is our answer for that situation. Okay, how about this one? Negative c to the 5th, negative c to the 5th plus 5 c to the 4th minus 12 minus the quantity 2c to the 5th minus c to the 4th. So we're going to drop the first set of parentheses because there's nothing in front of it. Distributing the subtraction, we get minus 2c to the 5th minus times minus plus c to the 4th. Combining like terms, those go together, those go together. Minus 1 c to the 5th minus 2 c to the 5th is negative 3 c to the 5th. 5 c to the 4th plus 1 c to the 4th is plus 6 c to the 4th. And finally, the constant term just minus 12. Okay with that? Questions there? All right. Let's see here. How about this one? This says subtract 2x squared minus 2x plus 3 from 3x squared plus 4x plus 5. So I'm subtracting that first trinomial from the second trinomial. We're going to come back to this in a minute. Suppose I said subtract A from B. You would write B minus A, correct? Or if I said, here, let's do this. Subtract 3 from 7. You'd write 7 minus 3. And then, of course, you'd get 4, right? So here, I'm going to subtract this from that. So I'm going to have 3x squared plus 4x plus 5 minus 2x squared minus 2x plus 3. Now, there's something wrong with what I've written there. Can anybody tell me what's wrong? Nope. Okay. I'm subtracting the entire polynomial from the entire polynomial. Now, if I don't group that first set, since there's nothing in front of it, that isn't going to matter. But I'm subtracting the entire trinomial. So if I don't put these parentheses in there, I only end up subtracting the first term, and then everything else changes, stays the same. So I need to group the quantity that's being subtracted. So now I get minus 2x squared, minus times minus plus 2x minus 3. So that's the tricky thing you got to watch for. Now, combining like terms, those go together, and those go together. 3x squared minus 2x squared is 1x squared. Again, don't put the implied 1. 4x plus 2x is 6x, and 5 minus 3 is plus 2. So there's our final answer. Okay. There's a couple of story problems in your WebAssign assignment that tend to get asked about a lot. So I'm going to see if I can draw some lovely pictures and kind of refresh or kind of give you an example of how this works. All right, so we've got, let's see here if I can draw this. We've got these two pillars. We've got the second one here. I know, I'm not much of an artist. Okay, the first one is, let's see here, x squared minus 3x plus 2 feet. And the second one is 5x minus 10 feet. Okay, so those are the heights of each one. Part A says, find a polynomial that represents the difference in the heights of the columns. So we would take the tallest column, minus the shorter column. Okay, so that gives us x squared minus 3x plus 2 minus 5x minus times minus 10 plus 10, and that's feet. Combining like terms, x squared minus 8x plus 12 feet. Okay, notice I've got the units attached outside the parentheses, because if you write x squared minus 8x plus 12 feet, the units of feet are only attached to the 12. That's why we need the parentheses around the whole thing. Okay, so there's part A. We're taking the tallest column minus the shortest column to get the difference. So we're finding basically that distance right there. Okay, now part B says if the columns were stacked one atop the other, who talks that way? to what height would they reach? So now we're going to add the two polynomials together. So we're going to take x squared minus 3x plus 2 feet plus 5x minus 10 feet. So x squared minus 3x plus 2 plus 5x minus 10 feet, which is x squared plus 2x minus 8 feet. So there's the length or the height of the two columns stacked together. All right. Any questions about that? Okay. Let's look at one more. This says subtract, and this time they have parentheses, 32x squared minus 17x plus 45 from the sum of 23x squared minus 12x minus 7 and negative 11x squared plus 12x plus 7. All right, so we're subtracting the first trinomial from the sum of the second two trinomials. If I were to write this all out as a single statement, I'd start with the two that I'm going to add together. So 23x squared minus 12x minus 7 plus negative 11x squared plus 12x plus 7 minus the quantity 32x squared minus 17x plus 45. Okay, so we're subtracting from the sum of those other two polynomials. Well, now let's go back and get rid of the grouping symbols. So this becomes 23x squared minus 12x minus 7, and then plus everything inside. So minus 11x squared plus 12x plus 7, and then distributing the subtraction sign, minus 32x squared, minus times minus is plus 17x, and minus times plus is minus 45. So now we've got a single polynomial. We'll go in and combine like terms, this and this and this. 23x squared minus 11x squared would be what? 12x squared. Minus 32x squared would be negative 20x squared so far. Okay. Then let's see here. Minus 12x plus 12x plus 17x. Minus 12x plus 12x, those would cancel out. So we've got plus 17x. Okay. And then let's see here. Minus 7 plus 7 minus 45. The minus 7 and the plus 7 would cancel. So we end up with minus 45. And here is our final answer. Okay, we're subtracting this from the sum of those two. So we're going to add those two and then subtract that. Now, we could have done that as two separate problems. We could have just taken those two and added them together and got results and then subtracted that, but we can do it all at once. Any questions about anything there? All right. So we're going to stop. Wait, I've got a question in the chat. Okay, there we go. So I'll stop the video, the recording,